Okay guys, so on the previous videos I've explained that there's huge chunks of the final that are on simplifying, huge chunks on the final, a huge part of the final that's on graphing quadratics, which are parabolas, a huge part on factoring. Now there's smaller parts of the final like graphing exponential growth and decay functions. There's only 2 questions out of the 38. So if you're an A student going for that A+, of course you want to know how to graph exponential growth and decay functions, right? So let's do a quick review here. An exponential growth or decay function is when you have a variable as an exponent. So like let's say I had y equals, let's say 2 in parentheses to the x power, okay? Now this is a growth function because the base is greater than 1. Okay, if the base is greater than 1, that means that it's going to grow from left to right. Okay, so from left to right, let me just do a quick sketch here. From left to right, if the base is greater than 1, it's going to grow. It seems like it's touching the x-axis, and then all of a sudden it grows exponentially from left to right. Okay, that's when your base is greater than 1. From left to right, it grows. Now that makes sense because if your base is greater than 1, like right here, the number 2. If you take any number and multiply it by 2, it's going to grow, right? So 10 times 2 is 20. It grew from 10 to 20. So if the base is greater than 1, it's going to grow. As opposed to if I had y equals, let's say, 1/2 to the x power, that's not going to grow. It's going to shrink, right? Let's think about that. If I take any number and multiply it by half, it's going to shrink. So like the number 20, 20 times 1/2 is 10. It got smaller. So what does a decay function look like? This base of 1/2 makes it a decay function. And a decay function from left to right, it decays to a certain value. So you're probably way up here somewhere. And from left to right, it decays, 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 decays. And it decays and it approaches that x-axis forever. Okay? Now, what if you actually had a plus or minus a certain number out here at the end? Okay, what that would do is it would shift that graph either up or down. So let's actually put a number out here. If I had a -1, if I had a -1 at the end of it all, actually let's make it a -2. What would that do? It would take that blue graph, which I call the parent graph, and it would shift it 2 units down. So what that would do is simply move that whole graph from left to right. It would still be a growth function, but it would shift it 2 units down. Does that make sense? So with that knowledge right there, guys, you'll be able to identify the correct answer even without doing much work. Okay. Let's say this one over here, the y equals 1/2, it's a decay function from left to right. It's decaying to a certain value. And let's say we actually had a number out here, like let's say plus 3, right? Plus 3. If you had a plus 3, then this parent graph, this blue graph that decays down to the y value of 0, that decays down to the x-axis, is going to get shifted 3 units up. So if I had like 1, 2, 3, the new graph would be up here, approaching that y value of 3. So again, why did I do this little mini lesson? Because just with that knowledge, you'll be able to identify which one's the correct answer. Okay? Let me actually go through and work out these problems as if it were an open response test, not a multiple choice test. I want to start with number 27 from the practice test. Once again, we look at this and we know it's not a parabola. Parabolas have the power of 2, and right here we have the power of x, right? So we know that it's an exponential function. It's either going to be a growth or a decay. What do you guys say? Is this a growth or is this a decay? It's a decay. Why is it a decay? That's a 1/3. That's less than 1. And if you take any number and multiply it by a value that's less than 1, like a fraction like 1/3, it's going to shrink. 30 times 1/3, that's actually 10, right? So it shrinks. 9 times 1/3, it shrinks to 3. So the base 1/3 means that it's a decay function. So you already know that from left to right, it's going to decay to a certain value. And that's really, it comes in handy when you have a multiple choice test like the final exam. But right here on the open response test, you actually have to do the old school way, XY table, right? And you want to plug in nice numbers like 0, 1, 2, maybe 3, and also backwards, -1, -2, -3. And I put it in order, that way we could see a pattern, or we could use the growth or decay factor, which is the base value of 1/3, to get from one output to the next. Now the easiest number to plug in would be what? 0. Well, anything to the 0 power equals what? 1. So anything to the 0 power equals 1. So 0, 1 is a coordinate. If I graph that, it's right here. Okay, that's not a vertex, it's not a parabola, right? But it is an easy number to get, 0, 1. Now, let's plug in a different one. If I plug in a 1 up here, what's 1/3 to the 1 power? 1/3. How about 1/3? That's hold on a second. What's 1/3 to the second power if I plug in 2? 1/9. What's 1/3 to the third power? 1/27. And what does that mean? That it keeps getting smaller and smaller and smaller, right? 1/3 of a tank of gas, you don't have that much gas. 1/9 of a tank of gas, you're almost empty. 1/27th, you're running on fumes, right? So let's actually go in the opposite route, or let's understand this, that the base 1/3 is another way of producing your outputs if your inputs are in order. So 1 times the base 1/3, that'll get you 1/3. Times 1/3, that'll get you 1/9. Times 1/3, that'll get you 1/27th. So going backwards would be the reciprocal of that, which would be dividing by 1/3, which is the same thing as multiplying by 3. In other words, 1/27th times 3 is 3/27ths, which reduces down to 1/9. 1/9 times 3 is 3/9ths, which reduces down to 1/3. 1/3 times 3 is 3/3, which reduces down to 1. 1 times 3 is 3, and then 3 times 3 is 9, and 9 times 3 is 27. So we have all the coordinates that we need. So let's actually graph more of these. Well, let's look at this one, 1 and 1/3. That means 1 on the x, and not even 1 up. I'm talking 1 on the x and 1/3 of the way up. It's not even halfway up. So we're going to put a dot right there, not even halfway up. And then 2 on the x and 1/9 of the way up. That's even smaller than 1/3, so it's even closer to the x-axis. Now at this point, 3 and 1/27th, it looks like it's actually touching the x-axis. So you could just draw dots. Even though we know that it never actually touches, it just infinitely approaches, you could draw the dots as if they were on the x-axis. Now going the other route, the -1 and 3. -1 on the x, 3 on the y, you're right there. -2 and 9, you're going to be off the graph. But anyways, here's a perfect graph. If it were an open response test, you would have to do this. Because it's multiple choice, you're going to be able to look at the 4 graphs that they give you, and you're going to say, oh, 1/3. So you're going to be able to eliminate the ones that go up from left to right, because those are growth functions. And there's probably only going to be 2 of these guys. And if it did have a number out here, that would be the shift, the difference on the shift, right? So for example, if I did have a -5 at the very end, I would have that same red exponential decay function, but 5 units down. So it would be down here instead of up there. Does that make sense?
So then the right answer would be the one on the bottom, right?
No, if I had, I just said if I had a -5. Yeah. If I had a -5, it would be this one down here, not the parent graph. But this one does not have -5. So let's erase this one. Let's not confuse anybody. I just said if we had a -5, you'd have to shift it 5 units down. So there's a couple more parts to this. Down here, it says, what's the Y-intercept? The Y-intercept is where it crosses the Y-axis, and obviously it crosses at the value of 1, or you could use the coordinate 0, 1. Either one is a good answer. The domain, the x values are really all real numbers, because this thing does go to the left forever. Even though it goes up, it goes to the left forever, and it goes that way forever. So with regards to the x's, it goes both left and right forever, so it's x equals all real numbers. Now the range is a little tricky, especially because we're so used to stating the range of a parabola, right? The range of the parabola is either y is greater than or equal to the y value of the vertex, or less than or equal to the y value of the vertex on parabolas. But right here, it's above a certain value, but the line never actually touches the y value of 0. Does that make sense? Again, it never touches the y value of 0. So it is above the y value of 0, but it never actually touches the y value of 0. So we're going to say that the range is y is greater than 0. We can't put the or equal to, because the or equal to implies that it actually does reach 0, and it never actually reaches, it just infinitely approaches. Now on this guy right here, we actually do have that -5, so we will have to shift it. So let's go through this a step at a time. I already know that from left to right it's going to grow because the base is 2, which is greater than 1, which causes it to grow from left to right. So let's take a look at the parent graph. What do I mean by that? I'm going to ignore the -5 for a little while, and at the end of it all, I'll shift it 5 units down. So let's come up with the XY table. Consecutive integer inputs. Let's plug in the easiest number, 0. And if we do plug in 0 right here, it'll be 2 to the 0, which is 1. Okay? And we're going to put a 1 right here. The output's 1. Now, notice I'm ignoring the -5. Okay? I mean, you don't have to ignore it, but I'm ignoring it, and I'm going to shift everything 5 units down. What I'm doing is I'm going to graph the parent graph first, and then I'll take the -5 into consideration. So when I plug in 0, I get out a 1. I don't worry about the -5. I just put the 1 right there. And I could use the growth factor to get the rest of my outputs. The growth factor is 2. The base is 2. So that output of 1, if I multiply it by 2, I'll get the next output, 2. And then if I multiply it by 2, I'll get the next output, 4. If I multiply it by 2, I'll get the next output, 8. Make sense? So again, I could use the base 2 to find the next outputs because the inputs are in order. 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8. Going backwards, it'd be the reciprocal, which is multiplying by half. 8 times half is 4, half of 4 is 2, half of 2 is 1, half of 1 is 1/2, and then 1/4, and then 1/8. So let's graph this. The coordinate 0, 1 is right here. The next coordinate is 1, 2. It's right there. The next coordinate is 2, 4, 2, 1, 2, 3, 4. It's right there. And 3, 8 is way up here on the edge. And going in the negative direction on x, -1 on the x, and then halfway up right there. And then -2, and then 1/4 of the way up, and then -3 and 1/8 of the way up. And at that point, they all look the same. They all look like if they're actually touching, but they never actually touch. They just infinitely approach. Now, if I did not have this -5, right? If I did not have it, like let's say it wasn't there, then that would be it. That would be my answer. But because I do have a -5 right there, I need to take every single one of these coordinates and shift them 5 units down. So this guy, you go 1, 2, 3, 4, 5, and put a dot right there. I might as well do all of them at once. So as you can see, I shifted them all 5 units down. 5 units down. This halfway 5 units down. Everything got shifted 5 units down. Every single coordinate. So my actual final graph is this exponential growth function that got shifted 5 units down. And you draw it like if it's actually touching the y line, the y equation of -5, but it never actually touches. It just infinitely approaches. So just for funsies here, what would the domain be? X equals all real numbers. Well, that's horrible. X equals all real numbers. How about the range? Y is what?
Not greater than.
Okay, so it's either above -5 or below -5.
Greater than -5.
It's greater than -5. Whoa. And it's definitely not greater than or equal to, it's just greater than -5 because it never actually touches. What else could we say? I don't know, I guess that's it. The Y-intercept, yeah, we could say the Y-intercept. It crosses right here, and that's -1, 2, 3, 4, so the Y-intercept is -4. I don't know, that's about it. There's only 2 of these problems. Again, this is for the A students. I want that A+. If you're just worried about scraping by with the C, I guess you could not study these. You could still pull off a C and not get these right.